All right, so today we're going to talk about, or continue our discussion about chemical reactions, but more specifically, we're going to talk about types of reactions. All right, so let's get right into it. So here we have a synthesis reaction. So this is where two things, 1, 2, go to make one thing. So I recommend writing the A plus B equals AB down. Thinking kind of, because what it's saying here is any compound doesn't matter, plus any compound doesn't particularly matter. As long as those two things go together to make one compound, that's a synthesis reaction. Okay? Once again, only one product forms. That's the key. So here's kind of like an algebraic example, if you want to call it that. Then here's a real example at the bottom. Okay? So we have a phosphorus plus a bromine go to make phosphorus tribromide here. Then you have to go back and balance it. Now, for our class, you're only going to need to be able to identify what type of reaction it is. You're not going to have to predict the outcome. So I'm not going to give you just this and this, and you have to figure out that it's going to make that. Okay, that's not what we're doing in this class. What you will have is something like this, either balanced or unbalanced, and you will have to identify what it is and tell me if it's unbalanced, then balance it. All right, that was the first one. Number 2. All right, so for here we have decomposition. So if you ever heard of the term before at all, decomposition means you kind of break stuff down. Okay, so in this one, we have one thing making two things. All right. So in this case, real world example, hydrogen peroxide breaking down into water and oxygen gas. Once again, we got one thing, we end up with two things, so that makes that a decomposition reaction. All right, so single replacement reactions, okay? So in this reaction, one thing, either the metal or the non-metal, gets replaced. All right? So, for example, when we use kind of our algebraic things, A was all by itself on the reactant side, but A ends up with C on the product side. Okay? So B was with C at the beginning, but now it's all by itself. So my real world horrible example that I've been given is your best friend, all right, is going out with some boy or girl, okay? They break up, they get back together with somebody else. So now the new boy or girl is with your friend, and the other boy or girl is all lonesome. All right? So, key here too is that a metal will only replace a metal, and a non-metal will only replace a non-metal. So, we'll give you kind of a real world example here. So, potassium plus sodium chloride go to make potassium chloride plus sodium. Okay? So, this is actually balanced as is. Everything is either negative charge, -1 charge, or +1. So, as is, it's nice and balanced. But the K swapped with the N. Okay? So, it kind of kicked it out. All right? It came in. And that is a single replacement reaction. All right, double displacement or double replacement, you'll see it written both ways. All right, in this example, two things swap. So, continuing with my absolutely horrible examples, you and your boyfriend have friends. All right, you and your boyfriend have another couple. All right, and y'all just like swap boyfriends. Like I said, these are horrible examples, but for some reason, students seem to remember horrible examples rather than real examples. So here, y'all were together. Now you're with each other's significant other. Okay. The positive cation will pair with a negative anion from the other one. Then your positive ion will connect with your negative ion over here. So you end up with AD, C, and B. All right? So in this, it doesn't matter what elements we're talking about. I'll do another quick, easy, simple example. All right? Salt plus calcium oxide. I don't really know if this is even a real reaction. Just coming up with this off the top of my head. All right. So they'll switch and we end up with sodium oxide plus calcium oops. Oh, erase that. Calcium chloride. Okay. Now we have to go back and balance it. Boom. So sodium was with the chlorine, now it's with the oxygen. Calcium was with the oxygen, now it's with the chlorine. That's a double displacement. With combustion reactions, a few things. In a combustion reaction, you always start with a hydrocarbon. It always bonds with or mixes with, however you want to look at it, with oxygen gas. You always make carbon dioxide and water. Always, 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 always. Okay? Always. All right, now, the X and the Y here are referring to like a variable. It can be anything. It doesn't matter what amount of carbon or amount of hydrogen you have, okay? It just matters that it's carbon and hydrogen, okay? So with my example, like right here, like we could have C5H12. We could have C2H2, acetylene. We could have C1H4, okay? Methane. We've got a whole bunch of options, but it doesn't matter, okay? If it's this one, if it's this one, if it's this one, all right? As long as it's a hydrocarbon mixed with the air, the oxygen in the air, and it gives you a carbon dioxide and water, it'll always be a combustion reaction. So those are the only 5 that we're going to need to know for this class. And remember, you're only identifying it and then balancing it. I do not expect you to know and be able to give you the reactants, and you give me the products. You all have products and reactants. You would just be expected to identify it and then balance it.